Hello and welcome to Lesson 8-2 on equations with two variables. In tonight's lesson, we're going to be able to find solutions of equations that have two variables, and you will also be able to graph these equations that have two variables. So in the past, we've talked about something like this, and in fact, this is from Lesson 7, or Chapter 7, where we have something like 2 times x plus 5 equals 7. And then our job was always to solve for x. So we'd subtract 5, be left with 2x is the same as 2. Divide by 2, and you'd say, oh, x is equal to 1. We have one answer, and we know that it's the number 1 here. But sometimes we'd have something like this, where we have two variables. Y is equal to 3x plus 4. Now here, we don't have something equaling 7 or equaling 1. Instead, they throw in this extra variable, this y. And this changes everything, because we start talking about solutions, which is when you can take an ordered pair that would make the solution true. For example, I could say, well, I have 3 times x plus 4 is equal to y. What if I put in for x the number 0? Well, and then I put it into that equation. Well, 3 times 0 is 0. Well, I can actually write that out. Oh, there we go. In fact, I'm going to fix that whole thing because I did not write that right. There, 3 times x plus 4. So 3 times 0 plus 4, and then I find out my y is 4. So if I put in 0, y pops out, or 4 pops out. If I put in 1, 3 times 1 plus 4, well, that's 7. If I put in negative 1, 3 times negative 1 plus 4, I get 1. So you can see how these ordered pairs would be a solution. 0, 4, 1, 7, and negative 1, 1. All of those are solutions to that two-variable equation. So here, we're going to find a solution. Find the solution of y is equal to 4 times x minus 3 if x is 2. Well, in this situation, they're telling us what to put in for x. So that's our first step. We're going to replace the variable they tell us with 2. And you can notice I put parentheses around this 2 because that way I know that's the number I put in. So I have 4 times 2 minus 3. Well, I multiply before I subtract, so I have 8 minus 3, which means it is 5. So my answer here is 5, and there we go. All right, and really, if I wrote it as an ordered pair, it'd be 2, 5. All right, so well, now we have this one. Find the solution of each equation for x is equal to negative 3. So again, first job, we're going to do A together, then I leave you with B and C. Y is equal to 2 times negative 3 plus 1. Well, that's a negative 6 plus 1. Well, y is negative 5. Or, as they ask for the solution, we can write it like that. All right, so your turn to do B and C. All right, so once you do them, go ahead and check back and see if your answers are correct. So go ahead and do that now. All right, let's check those, shall we? So I have y is equal to negative 4 times negative 3 plus 3. Well, two negatives make a positive 12 plus 3, which is 15. All right, and then finally C, I have y is equal to 0 times that negative 3 minus 4. Well, that is 0, and 0 minus 4 is negative 4. So those would be your answers. So that's the first part of today's lesson. And now we get it in a word problem. The equation A is equal to 5 plus 3 times P gives the price for admission to a park. In the equation, A is the admission price for one car with P people in it. Find the price of admission for a car with 4 people in it. All right, so we can take this equation and really break it apart if we wanted to. We know this whole equation tells us the price for admission into one park. So if I'm looking at it, A means the admission price, so the cost. This 5, I'm betting, is probably for just coming in for parking. It just costs you $5 down to go and park. And if you've ever been to like Valley Fair or Six Flags or something like that, normally you do have to pay just some money for parking. It doesn't matter how many people you have in the car for that. It's just for that one car, you have to pay so much money. So in this case, you pay $5 for the car. Then you also have to put in the price per person. And this 3 times P tells us that piece because it's $3 per person to get in there. All right, so now they say find the actual price if 4 people were to come into the park. Well, this 4 people is going to be this P, all right, because the 4 people isn't the admission cost, it's how many people are in the car. So A is equal to 5 plus 3 times 4, because that's the number of people. And now here I have 5 plus 3 times 4. Well, I do multiplication before I add. So 3 times 4 is 12 plus 5. That will cost $17. So the admission in this park is $17. All right, now we're to a big part, and this is a key thing you need to learn in 7th grade, and that is how to graph equations with 2 variables. Now when we graph lines, because that's what we're going to do, it's really called a linear. All right, so it's linear, or it's a linear equation here. So it's an equation whose graph is a straight line, and it's made up of many points. So when they say linear, again, it's like any of these. All right, now if I had a squiggly line, that's no longer a straight line. So all the ones in green are considered linear. Now here's how we do this, all right, these 3 steps. First, you make a table of values. So you need to try to find different solutions. All right, so you're going to try different numbers for the variable. Then you graph those pairs, and then you connect the dots, really. So here we have this one. Graph y is equal to 4x minus 2. First step, make a table of values. So we know we're going to talk about x. And I could put in here this 4x minus 2. And then I have my y. All right? Now, I usually tell my students to graph at least 3 points. But the more you do, the easier it is to actually graph. So what I have to do now is choose some values for x to put in, because that's what my function is. I have to figure out what can I put in for x that some number is going to pop out for y. I'm going to start with 0. So if I do 4 times 0 minus 2, well, 4 times 0 is 0, so I'm left with negative 2. All right? Then I could do 1. 4 times 1 minus 2, well, 4 times 1 is 4. Take 2 away, that is 2. I could do 2. 4 times 2 minus 2, well, 4 times 2 is 8, minus 2 is 6. And of course, you should do some negatives as well. I'm going to do a negative 1. 4 times negative 1 minus 2 is a negative 6. And let's see, I'm going to go ahead and just try a negative 3 maybe. 4 times negative 3 minus 2, well, that's negative 12, negative 14. So I have a table of values now. All right, and I could put them as an ordered pair. All right, if I wanted to here. And I'm just putting this all together and grouping it. That way I can make it a little smaller. So I could make these all ordered pairs now. So 0, negative 2. If I put in 1 for x, 2 pops out. If I put in 2, 6 pops out. If I put in negative 1, negative 6 comes out, and so on. Negative 3, negative 14. So I just made them all into ordered pairs. Step 2 is to graph them now. So I graph 0, negative 2. 1, 2. Let's see, 2, 6. Negative 1, negative 6. And then negative 3, and I'm off my graph, but I'm probably somewhere down here. And if you take a look, well, that was probably a little off. There we go. If we take a look, my third step now is to put those points together. All right, so I'm going to connect them. And forgive me, I don't have a straight edge. You really should use a straight edge when you do this. But this is the graph that matches that linear equation. All right, and you'll notice I put little arrows at the end because it means this graph continues. I just chose 5 different numbers for x. There's hundreds or thousands more you could put in. I just chose these ones because I knew they'd appear in my graph. All right, so now we have this one. It says graph y is equal to 2x plus 1, then determine if negative 1 is a solution. So here we have an extra step. Not only do we have to graph them, but then we have to see if negative 1 would actually be on that line or that graph. So here's what we're going to do. We're going to start with our table of values. I start with x. I can put in my 2x plus 1, and out pops y. And again, I like to start with 0. So 2 times 0 plus 1 is 1, 1. And you can see I kind of picked the same numbers because they work really well for me. All right, but I could pop up and say, oh, I'm going to put 5 in here. I could do that. You can skip around if you wanted to. It's just, well, then you get bigger numbers a lot of the times, and they're off the graph. And I'm going to do -2. Oops. I put my parenthesis in there a little too soon. 2 times -2 plus 1. Well, that's -4 plus 1 is -3. And I'm going to do one more negative number. And let's choose -4. Why not? 2 times -4 plus 1. That's -8 plus 1 is -7. So I have about 5 values, so I'm going to graph them. I have 0, 1, 1, 3, 5, 11, which is probably around here. Let's see, -2, -3, and -4, -7. There we go. I have my 5 points. So now I am going to connect the dots, put my arrows at the end, and there we go. I have it. However, now I have to check to see, is -1, -1 a solution? The best way for me to do it is I actually like to put that number on it. So I go to -1, -1. And that would be right here. So is that a solution? And it sure looks like it is because it's on our graph. So in this case, I'd say yes. And there we go. All right, so now it's your turn. I want you to go through those same steps that I've been going through. Make your table of values, graph them, connect the dots, and then see here if -2, 0 is a solution. So go ahead and pause me. And when you're all back, or all done, come back and check your answer. So pause me now. All right, let's check this one. So again, I'm going to start just with my table of values. Oops. Put my y in there a little too early. And I'm going to try to go pretty quick through this since you already have your work done. And you might notice you don't pick the same numbers that I do, but our graph should still turn out the same. All right? Because we're not always going to pick the same numbers. Let's see, 3 times -1 minus 2. All right, so I have my numbers, so now I'm going to graph them. So 0, -2, 1, 1, 2, 4, -1, -5, and -2, -8. There we go. So again, I connect those dots, and my line here was not very good, but there we go. And then I check if -2, 0 is a solution. Well, -2 is over here, and then 0 is right on there. So is that on the line? And in this case, no, it is not. So no, it is not a solution. All right, and final piece tonight is graphing when it's just y is equal to some number or x is equal to some number. Because you don't always just get diagonal lines. Sometimes you get straight ones, meaning horizontal or vertical lines. All right, and when that happens, it means a few certain things. If it's a vertical line, meaning it goes like this, it's written as x is equal to that number because it only goes through x. It doesn't have anything to do with y at that case. It goes through the x-axis. Now, if you have a horizontal line, like I'm drawing in red, it's y equals something. So again, I have this red one down here where it's a vertical line, and you write down where it passes. So vertical is x equals, because it passes through this x-axis here. It passes through at 4. So this horizontal line, all right, is written as y equals, and I check to see where it crosses that y-axis, and that's at 2. So on some of these, you just have to take a look and determine it. And then we can bring back yesterday's lesson on functions and that vertical line test. So we discussed functions, what type of line would not be considered a function. Well, it's called the vertical line test for a reason. So it'd be those vertical lines. So if you get a vertical line and they ask you if it's a function, meaning x equals something, it is not. Those, if you have an x equals some number, it is not a function. So here, graph each equation and then determine if it's a function. Well, y equals -3, meaning on this y-axis, it crosses at -3. All right, so when this happens, that means the rest of it is 0. So it's a there you go. All right, so you can say, I could put a whole bunch of points in here. All right, I really could. I could do, what I have shown here is 0, -3. But I could do 1, -3, or 2, -3. As long as y equals -3, all of them are going to be on this line. Okay, and then we take a look, is this considered a function? Well, yes, because if I did the vertical line test, it only crosses through one point at once. So yes, it's a function. And again, I just made those green lines to show you that it only crosses through at that one point. There we go. So same with b here, x equals 4. Well, if it's x, that means it's on the x-axis, and I find 4. And then x is always a vertical line. And this one, well, it's a vertical line or an x equals. So no, it is not a function, because if again, this line is made up of many points. So if I rolled a pencil over it or just drew a vertical line through it, I'd pass through all these points in green. So it does not make it a function. All right, so now I have 2 for you to do. I want you to graph y equals 2 and x equals 0, and then determine if each one's a function. So go ahead and do that, and when you're all done, come back and check your answer. So pause me now. All right, let's check this. Well, I have y equals 2, meaning on the y-axis, I meant 2, so it's going to go like that. And yes, it is a function because it is a horizontal line. Now here I have x equals 0. So on the x-axis I find 0. And this is going to go up and down because it's x equals. So it's a vertical line. And because it's vertical, it is not a function. There we go. All right. And then we have one more piece of it. Sorry, I lied. I thought we were done, but we aren't quite done. All right. So we've been practicing graphing. Well, sometimes when you graph these, they're not so nice, and they don't just say y is equal to 2x plus 1. Sometimes they give you one like this. 3x plus y is equal to -5. When they give you something like this, your first job is to change the equation or transform it so it's just y equals something. So for example, this first one, I have that 3x plus y is equal to -5. All right, so we need to solve it so it's just y equals, meaning we have to get rid of that 3x. If there's a 3x on that side, I'm going to want to subtract it to move it to the other side or to get rid of it. Because if I have a positive 3x, well, subtract that 3x to get rid of it. So now I have y is equal to, and I like to write it with the variable first. So I have y is equal to -3x minus 5. I cannot combine this because they're not like terms. So now I could do my solutions. I could make my table, graph it, and so on. Same with this one here. I have y minus x equals 5. Well, to get y up by itself, I have to get rid of the minus x by adding it. And now I'm left with y equals x plus 5. Now, if you wrote this as y equals 5 plus x, you'd still get the same numbers for a solution. Again, I just like to write it with my variable first. That's why I wrote it like that. So here we have this one, and it got a little messed up on here. It says solve y is equal, or y minus 1/2 x is 3 for y, then graph the equation. So again, we're going to go through this one super quick, or as quick as I can, and then we'll be done for the night. So here, I need to get y by itself, so I look, well, this minus 1/2 x is on the same side. So that's what I need to get rid of. And I do that by doing the opposite. Well, they're subtracting it, so I add it. So now y is equal to a positive 1/2 x plus 3. So now I make my table of values. All right, and I'm going to tell you right now, I'm probably going to pick only even numbers for x's because of this 1/2 in here. Because I don't want to have to graph like a 0.7 or 0.7 excuse me, 0.7 or 6/10 or anything like that. So I'm going to stick to even numbers. That's going to get rid of that denominator. Okay, so I have 1/2 times 0 plus 3. Well, that is 3. I'm going to try 2 now. Well, 1/2 times 2, those are reciprocals, so I know that's 1 plus 3 is 4. Let's see. Let's try, how about 8? 1/2 times 8 is 4, plus 3 is 7. And now I'm going to do some negatives. How about -4? 1/2 times -4 is -2, plus 3 is 1. And one more number just to even it out, -6. So 1/2 times -6 is -3, plus 3 is 0. So I have 5 values here, so now I graph them. So I have 0, 3, all right, 2, 4, 8, 7, let's see, -4, 1, and -6, 0. Well, I have my points, and I connect the dots. And there we go. That's my equation. All right, and again, we're not going to do that one. So that is tonight's lesson. Tonight we talked about how you can graph equations with 2 variables. And we start again with the table of values, graph those points, and then connect the dots. You have a great night, and I will see you all tomorrow.